Hi, this is Mr. Adams from Midwood High School, and this is a video on molality calculation. Okay, we've been doing the topic of solutions in class, and we've moved to the topic of concentration. We've tackled molarity, we've looked at parts per million, and this is a brief video on how we calculate molality. Very important, guys. In order to do concentration problems properly, you must know your solute from your solvent. Okay, it's very, very important. Also, guys, when you're taking a quiz or test, please read the questions carefully. Do no more, do no less than the question asks for. Okay, and the molality equation, molality is little m. Okay, molality is large M, capital M. Okay, it tells us that little m is equal to the moles of the solute. Okay, mole solutes over the kilograms of the solvent. Okay, so once again, it's very, very, very important that we know the solute from the solvent. Okay, all right. Now what's going to happen? You're going to pause the video and you'll do number 4, number 5, number 7, and number 8, and then we'll go over them together and see how we did. Okay. Okay, number 4. In this question, they're asking us to find molality. All right, so they're asking us to find the molality of this solution. They gave us 0.32 moles of aluminum chloride. Okay, and they told us that it has been dissolved. Okay, it's been dissolved in 2,200 grams of water. Okay, so we know that water is doing the dissolving. Okay, so we can assume that water is our solvent. We know that aluminum chloride is being dissolved, so we can assume that aluminum chloride is our solute. All right, so we take a peek at our equation right here. Okay, our solute goes in the top. Our solvent goes in the bottom. We divide these two in order to find our molality. Okay, so we look at it carefully. We see that we're given moles, and the equation calls for moles already. So 0.32 moles, okay, of aluminum chloride goes in the top. That's our solute. And in the bottom goes our mass of water. But before we throw the 2,200 under there, we have to realize that we need kilograms of solvent. All right, so we got to be careful. And once again, I like to put my triangles whenever I'm doing a problem. We have our little m, molality. We have our moles, okay, of solutes here. Okay, and over here in our solvent section, we have kilograms, kg of solvent. All right, the guy that's doing the dissolving. So what's going to happen, folks, is that before we do anything else, we have to find out how many kilograms are in 2,200 grams. All right, so we have 2,200 grams of water. Okay, we set up our conversion factor. We want to change that to kilograms, so we always put the thing we're looking for where? Yes, we put it in top, so our kilograms goes in the top. We want to cancel out grams of water. Okay, so what we do, we put grams of water in the bottom. All right, and we ask ourselves a simple question. Okay, how many grams are in a kilogram? Okay, so we know from experience 1,000 grams are equivalent to 1 kilogram. So grams and grams cancel. We have 2,200 times 1, that's 2,200, and we do a simple division. Okay, so that should give us approximately 2.2 kilograms. All right, and basically we're done. We get our calculators, and we do our division. 0.32 divided by 2.2 should give us around 0.145 little m, or 0.15 little m, if you're rounding for sig figs. Okay, so either or these guys are acceptable. Okay, and that's number 4. Very simple. Notice I was given moles of aluminum chloride, since that's my solute. Okay, and I need moles of solutes. I didn't have to do anything. I just use it as is. I was given grams of water. I didn't panic. I knew I needed kilograms. Okay, and I just simply converted it to kilograms there, and that's it. Okay, moving on. In this problem, we are trying to find, okay, the mass of water needed to prepare 1.2 little m of 0.6 moles of propylene glycol. Now, it sounds confusing and horrible and whatnot, but here's what you do, folks. Once again, before you do anything else, you set up your little triangle in the corner someplace, all right? I have my triangle. You work with the system, all right? I know my little m is equal to moles, okay, of solutes, over my kilograms, kg, of solvent, S-O-L-V for short. Okay, leave it like that. All right. Now, they're looking for mass of water, so we have to determine what water is. Now, 99.99999% of the time, water will be our solvent. Water will be doing the dissolving. So from that, we can assume that propylene glycol is our solute, right? So we need moles of solute, right? And it was just so happens that they gave us moles of solute. Good, so we don't have to stress that. We have our moles of solute. Now, we are looking for mass of water. We have to find it. It just so happens they also gave us little m over here. So in order to find the kilograms or mass of our solvent, we will do a division with the moles over the little m. Okay, so let's do that. We have 0.60 moles of our solute, propylene glycol, and we're going to divide that by 1.20 little m. And another way of writing little m is moles over kilograms. Okay, because it comes from over here, moles over kilograms. All right, so what's going to happen to our moles? Our moles will cancel, okay, and we're left with kilograms. So our answer sort of kind of makes sense, okay, in terms of how we set it up. So we will do that division right now. Okay, so put my calculator on here. I should have do this in my head. It looks like this is going to be 0.5. Let me just check it. Okay, I have 0.6 divided by 1.20 equals to 0.5. Yeah, cool. All right. So I'm going to have 0.5 kilograms. All right. They could have asked you for the mass in grams. Okay. If you want to turn kilograms into grams, you simply multiply by 1,000, and that will do that for you. But since they didn't specify, we can leave it as this for our kilograms of water. Okay. So that's another problem done. All right, moving on. Number 7. Number 7 is asking us to find molality, okay? But this time they gave us grams of sodium chloride, and they're telling us it was dissolved in a certain amount, 500 grams of water. So we'll set up our triangle in the corner someplace again, okay? Now, we don't have to do this every time, folks, but I just like to do it just to make sure that, my things are in the right place and everything's accounted for. So my little m is equivalent to moles of solutes, all right, over kilograms of solvent, S-O-L-V for short. All right, so I look at the problem. What am I trying to find? I am trying to find little m. All right, what am I given? Did they give me moles of solutes? I look at the problem. No, they didn't. I see that sodium chloride is being dissolved in water, so I know sodium chloride is my solute. All right, so they gave me grams of that guy. So I'm not going to panic Because if I have grams, if I have 13.7 grams of NaCl, sodium chloride, I know from chemistry 1, I can change that into moles pretty simply, all right? But I need the G word, or the G letters, all right? And that will be the GFM. So I'm going to put my conversion factor here, all right? I'm going to put grams of NaCl in the bottom, all right? Since I want to change it into moles, I want to find moles. I'm going to put moles in the top right here, all right? Okay, good. And from experience, 1 mole of any substance is equal to the GFM of that substance. So I'm going to look at my reference table. And I find that Na in group 1, Na has a mass of approximately 23.0. Okay, so I'm going to put that over here someplace. I got 23.0 for Na. And I'm going to check my mass of chlorine. Chlorine is approximately 35.5. So 23 and 35.5 gives me approximately 58.5. All right, so that's my GFM. Okay, so with my 58.5, okay, grams per mole as my GFM, I can now convert this to moles. All right, so I'm going to multiply across. All right, my grams and grams, they're going to cancel. So 13.7 times 1 is 13.7. So I'm going to put in my calculator, 13.7, and divided by 58.5, okay? So that's going to give me 0.234, approximately 0.234 moles, all right? So that's my moles of solid, moles of NaCl. So that's part of my problem done. I now need my solvent in kilograms. They gave me, okay, 500 grams of water. Okay, so if you forgot, we just simply put our conversion factor. We don't have to guess. Do we multiply? Do we divide by 1,000? No, you don't guess. You simply put, okay, our grams in the bottom. The thing you look for goes in the top. Kilograms goes in the top. We know that 1 kilogram is a larger guy. 1 kilogram is 1,000 of these guys. All right, 1,000 grams. The grams and the grams cancel. 500 times 1 is 500. Divided by 1,000. That would give us 0.5 kilograms of solvent water. So now we have our solvent value. We have our solute value. So what's going to happen next, folks, is we'll do a simple division. All right. So it's going to be 0.234 moles, all right, divided by 0.5 kilograms. We look at that, it makes sense. Moles over kilograms gives us molality, gives us little m. So when you divide by 0.5, it's just like you're doubling everything. So I'm thinking my answer should be like 0.468. Okay, I'll check in my calculator. So divide this guy by 0.5. Okay, 0.468. Yes. Okay, so final answer is 0.468 little m molality. Okay, so that's your answer right there. And you're done. All right. And we're moving on to the last one. Okay. In this problem, they're asking us how many grams of ethanol. They give us this formula right here, C2860. Okay. Looks like the empirical formula of it, are needed to prepare a molality solution of 0.1 molality using 1,000 kilograms of water. Now, it might seem convoluted, it might seem hard, but once again, you follow the system, you have your formula. The formula never ever changes, folks, so you don't panic. You know molality is equal to moles of your solutes, okay, over your kilograms of your SOLV, solvent, right? SOLV for short. All right, cool. You now have to determine what's what. Now, we said before, right? Water will be our, if we have water in this situation, water is going to be our solvent, right? Good. All right. Now, we look at the rest of the stuff. Now, we have this guy, ethanol, right here. So we can safely assume that's our solute. All right. Now they gave us the molality right here. So we are looking for grams, right? Grams of solutes. All right. We don't know the grams of solute. We're trying to find that. Now we ask ourselves a question. Which one of these three guys will easily give us grams of solutes? And it just so happens we know from Chem 1, moles of solutes can be easily converted into grams of solutes using the mole calculation formula. Okay, so what we're going to do, we look at our equation, we will multiply these two values, okay, kilograms and molality, and that's going to give us our moles, and then we'll work from there. Okay, so we have a molality of 0.10 little m, right? And another way of writing little m is moles per kilogram, right? Okay, and we are going to times that, that's our little m, 0.1, we're going to times that by the kilogram value. Okay, so kilograms of solvent is 1.000 kilograms, all right? So what's going to happen? Okay, our kilograms and kilograms cancel. 1 times 0.1 just so happens to be 0.1 also. But this time we've got our moles of solutes. All right? Okay, our solutes is C2H6O. All right, so our last step now is to find how many grams in that. And we're not going to panic. We know how to do that. So what I like to do, I set my conversion factor up. I have 0.10 moles, okay, of C2H6O. I set my conversion factor up. I do that. I'm looking for grams. I know I want to put moles in the bottom to make sure that the moles cancels. All right. And I need my GFM because 1 mole of any substance is equal to GFM of that substance. So I have C2H6O, right? Now I know that 2 carbons, okay, 2 carbons has a mass of 24 grams, 24.0. I know that 6 hydrogens have a mass of 6.0, so that's 30 up to now. And I know that oxygen, from experience, oxygen has a mass of about 16, right? Okay, so we got 30 right here. And we got 16 there, so 30 and 16 is 46. Okay, so 46.0 is my GFM. All right, my moles and moles cancel, and I have 0.10 times 46, so that's basically making it a tenth. So I'm looking at 4.60 grams as my mass of ethanol, of C2H6O. Okay. So what we did just now, guys, we did 4 molality problems. All right, very, very, very simple. Always, folks, always know your solute from your solvent. Read the question carefully. Know your triangle. Know your formula. You're good to go. I hope this video was a help. And as always, hard work plus sacrifice equals success. And I'm going to be working on a molality video in a second. All right, take care.